Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 19 of Physics 54, and we were doing the exercise in last lecture. Today we are moving one step ahead. We left the second question in the part number C. Today we are going to continue that. Question number 2 and part number C. Let us first understand that what part C is saying. A test car with a dummy driver of mass 60 kilogram. Mass of a dummy driver is 60 kilogram. We are writing the data as we are reading this question. Was propelled towards a rigid wall. If the speed of the dummy driver just before impact was 40 meter per second, so Vi is equal to 40 meter per second. Vi means initial speed. And when it hit the wall, came to the rest, so the final speed will be 0 meter per second. Let us move forward. And the time between the collision and the dummy coming to rest is 0. T is equal to 0.10 second. Now in the first part they are saying that calculate the average retardation of the dummy driver during the impact. We have to find the retardation. Ladies and gentlemen, you know that retardation is a name given to the negative acceleration. So the answer must be a negative. We are going to find the acceleration, and for that we need what? For that we need the uh, velocity and time is given. So velocity and time we have to write a. First of all, we are writing that delta V is equal to 0 minus 40, which is equal to minus 40 meter per second. Remember that the negative sign shows deceleration, negative, and they want us to find deceleration, so there must be a negative one. Now A is equal to delta V divided by T. So delta V is minus 40 and this is 0.10, and that will be meter per second square, because the unit of acceleration is meter per second square. So when we calculate it by the calculator, so it means that the answer will be minus 400 meter per second square. And that was the answer of part number 1. Now we found the acceleration. In the second part they wanted us to find the average force acting on the dummy driver due to the impact. So in the second part we have to find F is from Newton's second law of motion, from the Newton's second law of motion, F is equal to ma. So putting the the given values, we get F is equal to M is given as 60 kilogram, and A we found 400 gram, and that will be Newton because the unit of force is Newton. So when we calculate this, we will get the required answer. And let us calculate this first by multiplying this 60, 400 multiplied by 60. So 0, 0, 0 and 24,000. So it means that it will be 24,000 Newton, and we can write that is 10 raised to the power 3 Newton, and we can write 24 kilonewton. So this is the answer of part number 2 of part C. So now we are turning our focus to question number 4. Let us see what question number 4 is saying. Question number 3, not 4, question number 3. Uh, Question number 3 is saying the Republic of Singapore Air Force was the AIM-9 Sidewinder air-to-air missile, which has a mass of 86.5 kilogram. So mass is given, 86.5 kilogram of mass is given uh, of the missile. If the missile can accelerate from 300 meter per second to 700 meter per second, so final velocity is 700 meter per second, and initial velocity is 300 meter per second. So we have to find the delta V, and delta V is change in velocity. So minus 300, which will be equal to 400 meter per second. 700 minus 400 meter, minus 300 meter per second. Time is given. So time is given is the 6 second. So it is 6 seconds. Now they are asking to what is the average force exerted on the missile. We have to find the average force. Ladies and gentlemen, all the data is given. So as we know that F is equal to MA, but for that we need A. M is given, but A is not. For A, data is given. A is equal to delta V divided by T. So delta V is 400 and T is given as 6. And that will be meter per second square. Ladies and gentlemen, when we divide it so, A is equal to 6.66. We are given 6 second. Yes, 6.66 and they is going, so we are only writing 6.67 meter per second square. Now, putting the values of A and M in equation 1, we get, and that will be equal to F is equal to M. M is given as 86.5, and we calculated this uh, A is 6.67, and that will be Newton. So let us calculate this N. I calculated it 5766.9 Newton. So we can write it as 5.77, I should write, and into 10 raised to the power 3 Newton. And as a result, I can write 5.77 kilo Newton, because in prefixes we learned that 10 raised to the power 3 is equal to kilo. You have to remember this. That was the whole story about question number 3. Now we are turning our focus to question number 4. Let us first understand the question. A Pratt and Whitney PW4000 turbofan engine is able to provide a maximum thrust of 2.49 into 10 raised to the power 5. Ladies and gentlemen, if you visited a place in the aeroplane, so at the beginning of the airport, the engine of the aeroplane giving a thrust to the aeroplane. The question is saying that the thrust is also a force which is pushing the aeroplane. So we will write thrust as a force, and they given us this force as 2.49 into 10 raised to the power 5 Newton. Okay, that is the first available data. If the maximum, a Boeing 747-400, this is the airliner number, has 4 of these engines. So we have to multiply this for 4 engines. For 4 engines, F is equal to 4 into 2.9 4 9 into 10 raised to the power 5 Newton. Ladies and gentlemen, when you multiply this with this, so it will become 9.9 into 10 raised to the power 5 Newton. So 4 engine will provide a uh, thrust of 9.9 into 10 raised to the power 5 Newton. Rather, it is 9.96 into 10 raised to the power 5 Newton. Okay, let's move forward. What the question is saying, four of these engine, if its mass is also given as 2.72 2.72 into 10 raised to the power 5 kilogram. This is the mass of the engine. What is the acceleration at take off? What is the acceleration at take off? Ladies and gentlemen, by looking at the first glance, we say F is there, M is there, A is there. So it means we have to use the Newton second law. Here we are solving this as F is equal to MA. So we are finding A. This implies that A is equal to F divided by M. Now F is given as 9.96 into 10 raised to the power 5 Newton, and mass is given as 2.72 into 10 raised to the power 5 kilogram. So this will be cancelled with this 10 raised to the power 5, and when we divide this acceleration, a 9.96 divided by 2.72, so we will get 3.66 3.66 meter per second square, and that is the ultimate answer. Now we are turning our focus to the next question, and that is question number 5. Question number 5 is a theoretical one. So we have to deal it theoretically, not numerically. Let us understand the question first. Listen, ladies and gentlemen, carefully. Forces applied to a body may, and number 1 is saying cause it to accelerate. Cause it to accelerate. Number B part is saying change its shape. Change its shape. And third one is saying uh, change its size. Change its size. Ladies and gentlemen, again I am repeating, if force is applied, that force can do these three things. And the question is saying, give one example to demonstrate each of these effects. Make clear in each case the object to which the forces are applied and how they are applied. So we have to give one example of each. number one part. And how they, this is very important, how they are applied to that object causes to acceleration. The petrol or petrol inside the car tank is having chemical energy. Chemical energy. When the ignition switch is turned on, the chemical energy is converted to heat energy, which causes the car to accelerate. The car to accelerate. Now this is the first. Now the second, change its shape. When we hit a metal with a heavy hammer, it change the shape of metal. It changed the shape of the metal. When we drag the hammer upward, potential energy is stored in the hammer, and when we are hitting the metal with hammer, then potential energy is converted to kinetic energy, which in turn is converted to sound and light energy, and change the shape of metal. Third case is saying when we apply a force on both sides of a rubber band, then potential energy stored in the rubber band will change the size of rubber band. Okay, ladies and gentlemen, there is another part of this question as well. And at the end, they are saying that in some circumstances, the application of a force produces no apparent effect. In certain time, we are applying the force, but it is not producing any effect. State and explain one example of this. Yeah, this is, I will say, B part. Let us say this is A part. It is not given in the book, but we are giving from our own side. When we apply a force on a wall, it does not produce any acceleration, not apparent acceleration. So this is the example of that when sometime we are applying the force, but it is not apparently shown that the wall is producing any impact, any acceleration in it. So that is the answer of the uh, second part of this. They are saying that whenever we apply a force, sometime in some circumstances it does not produce any apparent effect. So that is what, if you are pushing, you are applying a force on a big truck or trolley, you are providing the force, but it is not showing any apparent effect because due to large inertia, it is not being able to produce any of the effect. Okay, ladies and gentlemen, now we are doing question number 6 because we are running out of time. So I wrote in advance for you people this. This is very easy, not that much difficult. Let us understand the question. The test to test the safety of a car and its passengers, a test vehicle was propelled at various speeds towards a fixed metal barrier. In one such test, the mass of the dummy driver was 75 kg. The speed of the dummy driver immediately before his impact was 30 meter per second. So mass is given as 75, V is given as 30 meter per second, and then if the time between the impact and the dummy driver, the dummy coming to the rest was 0.15 second. So what is number one part? The deceleration of the dummy driver. So ladies and gentlemen, A is equal to rate of change of velocity with respect to time. So minus 30 divided by 1.5 will give you minus 200 meter per second square. This is the first part. And the second part is saying the average force on the dummy driver caused by its impact. So F is equal to MA. M is given as 75. A is 200 Newton we calculated. So when we multiply 15,000 or 15 kilonewton is the answer. Not a big deal. It was an easy question. Okay, another part is saying explain why the wearing of a seat belt could reduce injury to a car driver. So seat belt reduces the chances of injury because it will prevent rapid ejection of the car driver from the window, which can cause certain death or severe injury. Why? Because the body is having kinetic energy when the car is moving fastly. The car suddenly become at rest, but the body is moving still with that kinetic energy. So during the accident, if you are wearing a seat belt, then it means that that kinetic energy will be prevented by the seat belt and will reduce the chances of injury. I wrote this: the seat belt will act to scatter the kinetic energy of the body, which is released on rapid acceleration. So that is why seat belt is very important. Ladies and gentlemen, that's it for today. Tomorrow we will do the remaining questions, which are 7 number question and only one question, but that is a very large question. We have to give a greater look to that, in-depth look to that. For that, you have to subscribe my channel and share these videos if you like it with your friends and family members. Thank you very much for watching. Allah Hafiz.